Last time we covered variables, so now we move into conditions. This is where programs begin making decisions. So we open Google Colab. Let's go with the hello or a new one. It's all the same. So this is what we were working on last time. I will just delete all cells. New one. Always the first time it takes a little while, like it loads, because the next time it's always faster. There we go. Conditionals are based on Boolean values. It's either true or false. That's it, nothing more. True. There we go, true is true. False. These are the built-in type of data Python can store. Boolean, it stores either true or false. We can store the Boolean in a variable. Well, not yet. Marine right, no. Print Marinte. True, false. After this Boolean true or false, we have comparison operators. Conditions usually compare two values. For example, uh, 10 greater than 5. So this whole comparison will return either true or false. In this case, true. Like the other way around, a whole bunch of these. And then greater than 10. Remember last time when it's only one, it's not asking is this equal to this, it's assigning. So here it would be, it would shout at us. That's why the little red squiggly line. We need to put two of them. So now this is the comparison operator. Is 10 equal to 5? Equal to 10, for example. Now, the opposite side of this would be an exclamation and then the equal. And then this is asking, is this not equal to 5? And then we have the less than or equal. And the other way, it's greater than or equal. So 10, 10. So if we run this, let's see, 10 less than, is 10 less than 5 true? Is 10 greater? True. Is 10 equal to 5? False. Is 10 equal to 10? True. 10 not equal to 5? True. And then these two are also true because we added the less than or equal, so it would also have worked with 8. 8 is less than or equal. Also true. So just to comment more about this equal, equal, or equal. For example, here it is not asking crew equals straw hats. Remember, this one is assigning the data stored in memory, the string stored in memory, straw hats. It is assigning it to a variable crew. So this points to this. Now here we are asking, is this string equal to what this variable points to? Let's see. True, because crew points to straw hat, and Python does this, so it compares to what is stored here, not to the actual pointer or address in memory. What would happen if I just put 1? It will assign it again. Type error. So we cannot assign strings to variables inside the function print. We could have done it like this again, assign it again, right? Nothing. That's it. And then it's still the same thing, right? Okay. So then, after all this, what are these booleans very used for? For if statements. An if statement runs code only if the conditional is true. If this is true, then do this. So, for example, then if bounty is greater than, let's say, 50 berries, chopper's bounty, then print bounty is high. Let's run this. There, bounty is high because the bounty is 500, and we are asking if the bounty is greater than 50, then print this. This space right here on the if after the colon, this is the syntax for the if statement. This is important. If, then a comparison. We could have placed it inside parentheses like this, and it's all the same. Bounty is high. The important thing is this. We have if, then a comparison in parentheses, then the colon, and what is indented is part of the if. So when this is true, it will run what's indented. If we would have put it here, well, right now it would have been a mistake because the if has nothing to run, but print this will print anyways. No matter if this is true or false. If this is true or false, only includes what's indented, with little spaces here. So for example, if bounty, a 10 bounty, the bounty is not high, so it will not print this, but it will print this next line, because this next line is part of the regular program. It's not indented. So as a side effect of this demonstration of the indentation, we already covered the true or the false. We already did if bounty equals 500, which makes this true, print bounty is high, and if this is lower, means this would be false, then it does not do whatever is indented inside this if. Now, there is part of these conditionals, there is also another Python command named or called else. This runs if this is true, runs this. If this is false, it skips this indentation and then comes and runs this. So let's go back to making the statement true, 500. So 500 is bigger than 50, so it prints this, and it will not print this low. Bounty is high. So then if we had a bounty with a value of say 40 and we run it, now bounty is low. So now after this else, there is one more command, Python command to use in these conditionals. I would assume it's else if, but no, elif. I do not know why, but elif so elif also asks questions. Bounty greater than 50. $100. Bounty is let's just put meat. So it keeps asking. The last one, I guess it's shouting at me because no quick fist. I guess the last one has to be else. Let's just run this. Chopper level. Because bounty is 40. Is bounty greater? No. Else. Else if. Is bounty greater than 50? No. So we're down at the bottom. Chopper level. So 120. Run. Bounty is high. It's greater than this? Yes. Prints this and then skips the whole thing, the rest. Let's say, for example, now 80. This will fall in the middle, right? More than 100? No. So it will skip this part. Then greater than 50? True. So then it must print this one, right? Let's see. There we go. Bounty is meat. if elif. Because it had no conditional. I guess the last one could be a elif, but if we do have a conditional, so the last one we could resort to, if it's less than 50, just do this, or just don't do it. Depends on the logic you want, right? So greater than 100, greater than 50, exactly 50, less than 50. Let's try it. 50, chopper. 49, hello world, which is the last one. And corner casers, the biggest one, bounty is high, and then 80, bounty is mid. Okay, so that settles it. So, more important, in these conditionals, we can combine questions like, if this is true and this is true, or if this is true or this other thing is true, or not true. If this is not true, then do this. We have 3 of them. And, or, and not. So let's see how they work. Has ship equals true. Has crew equals true. And then we ask ourselves a few questions. For example, if has ship and has crew, colon, then tab or indentation, then print ready to sail. Let's run this. Boom. Now the or is very simple, right? Self-explanatory, like either one of these can be true and still ready to sail. So this one, but if both of them are false, then not ready to sail. As long as one of them is true, we're ready to sail. Now, the one that is not so easy to intuitively is a not. The not is, I think of it like just switching the symbols around. Because if we ask, is captain if captain print we have captain, but since captain is false, because we do not have captain. Now, if captain is false and we run this, well, this is false, so this will not be printed. But if not, captain, Then print we have no captain. See, we have no captain. Why? It's a double negative, makes it positive. I know it's weird for me, very not so intuitive, but I think of it that way. If this is negative, which it is because captain is false, and we're asking if it's not captain, and this is false. If not false, then true. I don't know. I know it's weird, but that's how this works. Nested conditions. So conditions can exist inside other conditions. I know. Weird, no? I try not to do this too much. Crew. Then we ask if bounty is greater than 500, which will make this true. Then print dangerous pirate. Then inside this, because we are still indented, right? So this line will still be inside this if. So if has crew, print not alone. So let's run this. Dangerous pirate and not alone, because this is inside this. For example, since this will be false, it will just skip everything altogether. Even if the crew has crew, not alone, yes, he's not alone, but it will never even get to this. See? So there's a few stuff in coding like Truthy and falsy programs use or do certain values automatically, evaluate them as true or false, even though they are not a Boolean. So let's do an example. Name equals and then an empty string like this. And let's see if name print name exists, then else print or empty name, which would be false, right? This if true, then this. So if this were false, it will print this, right? So let's see what this empty name. So the evaluation of this is that it evaluates an empty string as false or falsy. Now if name exists, here we go. So if the variable contains a string, it evaluates to true or truthy, and if the string is empty, it evaluates to false. Again, this evaluates to false, empty name, just with a space. Name exists, and even though it's an empty, it's a space, but space counts as a character stored in memory. Name exists. So conditionals are actually very important because they are actually what starts to make little working programs. Let's write one, for example. if money greater or equal than 100, then print can buy meat. Else print So what this little program will do, now it's using this again special character word in Python. This is a function, a built-in function that will prompt the user for input on the screen, and what it inputs, it will return a string. So that's why we need this other special function we saw last time, which converts a string that looks like an integer into an integer. Let's run this. Berries. See, it's asking for my input and it's waiting. So let's say we only have 50. Enter. Not enough berries. This is not working well. This is like this. Again, berries, now 120. Enter. Can buy meat. So the syntax, some mistakes. If I were to forget one of these and I run it, it screams at me, right? And I think that's it. So conditions are the first step toward real programming logic. If these do this, if not, that do the other, so they can react to data instead of only running one line at a time, like this. And I think that's it for this video. I hope you liked it. Thank you very much. See you in the next one.